Designing objects. From a software perspective, those items selected are referred to as objects, such as custom class or struct. You would further refine those objects to hold members, which define attributes and behavior. Example of a C# program that uses object. This session shows you how to create objects and define their members. The attributes and behavior would map to C# language elements. An attribute could be a field or property, and a behavior could be a method or event. This is the world of objects, and by building objects that represent real-world entities, you can build more meaningful systems. Object members. In .NET, objects are self-contained with a single purpose in mind. All included members should be compatible. Here's a simple class skeleton. In this example, the class keyword tells that this is a class, a custom reference type. The name website is the name of the class, and the class members are contained within the braces. This could have been a struct instead, but that would have made it a value type. Instance and static members. Each member of an object can be classified in one of two ways: instance member or static member. When a copy of an object is created, it is considered instantiated. At that point, the object exists as a sole entity with its own set of attributes and behavior. If a second instance of that object were created, it would normally have a separate set of data from that of the first object instance. In C#, object members belong to the instance unless modified as static. An example of instance objects is a customer class, where every customer has different information. Fields. Fields comprise the primary data portion of a class. Examples of C# program for fields. They are the state of an object. They are members of a class as opposed to local variables, which are defined inside of methods and properties. Constants are efficient. Their values are known at compile time. This enables certain optimizations unavailable to other types of fields. By definition, constants are also static. Read-only fields are similar to constant fields in that they can't be modified after initialization. The biggest difference between the two is when they are initialized. Constants are initialized during compilation, and read-only files are initialized during runtime. Methods. Methods are some of the most common object members you will work with. A C# method is similar to functions, procedures, subroutines, and so on in other programming languages. The preceding method doesn't return any value, which is why you see the void return type. The name is my method, and you would replace that with a meaningful name of what the method does. This method doesn't accept parameters, coding methods, and custom operators. For now, here's a simple example. Properties. A C# property enables you to protect access to the state of your object. You use them like fields, but they operate much like methods. The following sections show you how to declare and use properties. Declaring properties. The get and set accessors can have any logic you want to define. A get accessor returns a value, and the set accessor sets a value. Notice the value keyword in the set accessor. It holds whatever value was assigned to the property. Using properties. Here's an example to show you how a property can be used. Auto-implemented properties. This rating property encapsulates some value of type int. Because calling quotes doesn't have access to the backing store anyway, knowing its name doesn't matter. The C# compiler will create an int field behind the scenes for us. Here's an example of a simple property. Indexers. Indexers behave like arrays in that they use the square bracket syntax to access their members. The .NET collection classes use indexers to accomplish the same goals. Their elements are accessed by index. Indexers are implemented like properties because they have get and set accessors following the same syntax. Given an index, they obtain and return an appropriate value with a get access, or similarly they set the value or respond to the index with the value passed into the indexer.